Welcome, class, to Chromosomal and Genetic Mutations. I am your teacher, Mr. Mora, and I hope you enjoy this presentation. First of all, before we get started on mutations, we need to review the central dogma of molecular biology, and it states that DNA makes RNA, which RNA makes protein. And here you see the 4 nitrogen bases that are contained in DNA, and the first one being adenine, then thymine, guanine, and cytosine. And if we look at the chromosome, that DNA is tightly packed in it. When it gets unwound, we can see that a little section of that DNA codes for a gene. And when that gene is transcribed and translated, then we have this amino acid sequence that is being built here, and it makes this protein. So what happens when all of this making of proteins or chromosomes goes wrong? Well, it's all about timing and scale. For instance, if a mutation happens during meiosis, it will forever change the gametes being formed here. And generally, when that happens, it is a larger event, a more devastating event to those gametes being formed. And if it happens during mitosis, usually it is as a result, a direct result from something that we are exposed to, either from the environment or something that we ingest into our body. And we'll take a look at both of these. Now first we're going to see chromosomal mutations. And you can see here on this chromosome you have an A, B, C, D, E, and F. Nice and simple. Here, if one of those gets deleted, you see that a piece or a function of this chromosome has been taken away, and that is as a result of a deletion. You can also have a duplication. Let's say that B gets lost here. Well, if it comes in here, then you have extra genetic information, and that can cause problems for that chromosome as well. And during these two examples right here, either inversion or translocation, all of the genetic information is there and available for that person to use. However, the instructions are switched around, and it may cause problems because of the order is incorrect. Now we're going to look at gene mutations. Gene mutations are on a smaller scale, however they can be equally as devastating. You can see here, this is the portion of the DNA that we're looking at. So we're going to expand on it and look at those messenger RNA strands being made. Here you see the textbook strand being made, and this is the amino acid sequence that the body needs. And if you look down here, just one change in a nitrogen base causes that amino acid sequence to be changed, making that a missense mutation. Again, here we have another area being changed in that messenger RNA sequence being made, and that causes a stop codon to be produced, and that is a nonsense amino acid / protein that the body cannot use. Here we're going to talk about a frameshift mutation, and that happens either with a deletion or an insertion of a single nitrogen base, and we know that this will change the whole frame being read and forever changing this amino acid sequence, causing a protein to be made that the body cannot use. So this is a result of things that we take in from our environment. Carcinogenic things such as drugs, not the prescribed ones, the bad drugs. Things such as cigarettes, cigars, tobacco products. Could be even exposure to sun. Too much exposure, that is. Now for our review, we talked about the central dogma of molecular biology, which states that, again, DNA makes RNA, RNA makes protein. And we talked about this and what is the difference between a chromosomal mutation and a gene mutation. It's all about timing and scale. If it happens during meiosis, you will have a certain result, and if it happens during mitosis, you will have a different result as well. Remember, we spoke about chromosomal mutations, what happened which will happen to a chromosome like this one, and it can be fatal to that baby being born, or also it can be a negative consequence. Or we can have a gene mutation, and the nitrogen bases are represented here by this necklace, and this can result in an improper protein formation or a serious health problem in the future for that individual. Thank you for spending some time with me reviewing chromosomal and genetic mutations. You have a great day.